at an application problem involving a parabola and domain and range and some key points along the graph. Here is a sample question about Timmy falling off of a cliff for a movie stunt. His height at any time is h of t equals negative 16 t squared plus 40x. Draw a graph of Timmy's fall, label the x-axis and the most important points. We're just going to identify the points that are requested, but we could graph this by touching the graph on Desmos and adding points to our graph. Let's look at Desmos and see what we have here. So here I have graphed negative 16x squared plus 40x, because you want to use x instead of t. But x represents time in the scenario. So the first question is, what is Timmy's height after 1 second? Now, to find the height after 1 second, and this graph is kind of counting by some weird numbers because I had to zoom to make it where I could see some things on here. So if they give you an x value and it's not one of your normal ones that are the points that are showing up here in gray, what I really like to do is add in a line that is x equals to that x value. So they want to know after 1 second. So make it x equals 1, and then you can see where the green and the blue is crossing, and you can touch that point now. So that point is 1, 24. So that point, I'm going to go over here and write down what that is talking about. So the point 1, 24 means that after 1 second, because 1 is the x value, his height is, because this represents his height at any time, his height is 24, and trying to see, did they give us feet or anything like that? I'm not sure of the unit because I'm not seeing it in the problem. I'm just going to say his height is 24. What is Timmy's maximum height? To find Timmy's maximum height, we need to go over here into Desmos and touch the vertex of the blue graph. And so right here is the vertex at 1.25, 25. And they want the height specifically. So this point is the maximum for the graph, but the maximum height of the graph is the y value. So 25 is the maximum height, and this height is reached at a time of 1.25 seconds. And that's the second part here. When does Timmy reach the maximum height? 1.25 seconds. When will Timmy land? Now, that landing is the x-intercept of the graph. We can see right here. 2.5 seconds, he will be at a height of 0. So that point is 2.5, 0, but the point is not the answer. We do need to say, what we're talking about. We're talking about when, and when is the x value. So 2.5 seconds. What is a reasonable domain for the situation? Now, he's not going to go into the ground. So the reasonable domain for the situation is going to be, from his starting 0 seconds to where he's ending, where he's landing again. He falls off a cliff, his height any time. So it's weird that it does have like his beginning height at 0, and that how high is the cliff? So we're just going with the graph that they gave us. Probably this graph is missing some information to it, but looking at this graph, you cannot go back in time, so the lowest time would be a 0, less than or equal to x, less than or equal to 2.5 seconds. So this is our domain because it's the x values for which the scenario is making sense. And then the reasonable range is he is going to be able to reach the ground, and he will have a highest point, which is 25 is the highest y value. So the lowest y value is 0, and the highest y value is 25. And that's the domain and the range for this particular graph.